Okay, hello everyone. I'm Natalya Bailey, founder and CTO of Accion-Systems, and I'm very excited to be talking to you today because it's a very exciting time in the space industry. You may have seen Northrop Grumman's MEV-2 just docked with a second Intelsat satellite, extending its lifetime by another 5 years. Which is just so cool and feels like the future of space. It's happening now. It's wild. And, that said, a lot of these advanced new missions, they require maneuverability. Satellites without engines and without maneuverability just stay put and eventually fall out of orbit and burn up in the atmosphere. So this exciting future requires that every spacecraft, satellite, probe have a very capable mobility. And engines that provided this maneuverability for the past several decades aren't particularly well suited to these new advanced types of missions or this new paradigm that a lot of the new entrants into the industry are embracing, like lower cost and smaller size. So from the Space Propulsion Lab, my co-founder and I spun out the ion electrospray technology as Axion's first product to be the future of mobility for all spacecraft once they're dropped off in orbit after launch. Our technology uses electrical energy to accelerate ions out the back of the spacecraft, producing thrust. And what we do very differently is that we use an inert, safe liquid propellant in an electric engine. So this is very unique, and all of our advantages really stem from this. We can use simple MEMS fabrication, and we're experimenting with 3D printing. We have unpressurized tanks instead of 200 atmosphere pressure vessels, which are like little bombs on orbit, and everything is very compact. So our first ion engine was the size of a pack of gum, whereas traditionally they've been about the size of a Prius. And we're really just at kind of the cusp of the really promising performance potential of the technology. One day we hope to get close to this thrust and power limit where we could maneuver the entire International Space Station with just 2 of our square centimeter chips. Our technology can span the entire industry, and I'll share, a very forward-looking use case with you that I think will become even more important as space becomes more crowded. On SpaceX's constellation of 10,000 satellites, because they're launched with pressurized xenon, each tank carries the equivalent of about 1/3 of a kilogram of TNT in stored energy. And there's a 6% chance over the lifetime of each satellite that it's impacted by debris that's already up there in orbit. And then there's, a non-zero chance that impact punctures that tank and leads to that release of the stored energy, which then creates a lot more debris. We ran a Monte Carlo simulation, and in about 50% of the cases, by 3.5 years into the mission, so only half the lifetime, the entire constellation was destroyed in a chain reaction. So that's about a $3.5 billion loss because of this early demise of the constellation, and it's all because of that pressurized propellant tank. So we think going forward, it's going to be really important to use a propellant like ours. Relatedly, we have a call to action and a partnership ask for anyone that has the FCC's ear. So it's hard as a small startup to dedicate a lot of time to influence regulations, but we've had good responses from some bigger companies that would like to work together on this, and we're looking for more. And then another ask is to big primes, the aerospace primes that may have a part in bidding on the SDA's transport layer. So this is sort of like a government version of SpaceX's communication constellation. We provide a subsystem, and although it's a very important, critical one, really the way to start to work on government business is by partnering with a bigger company that's delivering a complete solution. So if anyone out there needs a small business partner on SDA work, I look forward to hearing from you. Thank you for the time.